All right, so let's look at example 2. It says let r of x equal, and it gave us a rational function there. Determine the real number values of x that cause r of x to be 0, undefined, positive, and negative. So now they give us a rational function versus example 1 that just had a polynomial function. So think back when we were graphing the rational functions. What's another word for a 0 again? X-intercept, right? So for A here, it asks for the 0, but really we're going to find the x-intercept. And how did we find the x-intercept when we were dealing with rational functions? Yeah, the numerator was equal to 0. So I'm just going to work that out right here above it. So our numerator is going to equal 0. And so we know that x plus 3 times x minus 5 has to equal 0. And then we're going to separate them. So x plus 3 is equal 0, and x minus 5 has to equal 0. And solve for x. And so we found our zeros are going to be at -3 and at +5. Now B wants us to find where it's going to be undefined. What makes a fraction undefined? When you have 0 in the denominator. And what was it called when we had our denominator was equal to 0?
Domain.
It was part of the domain. And we had holes, and what was the other thing that was in the domain? I mean, that was the restriction. What else was it? Vertical asymptotes. So remember, the holes were the canceled factors of the denominator equal to 0, and the vertical asymptote was the uncanceled factors of the denominator equal to 0. So if they don't cancel and they're 0, that's where it's going to be undefined, right? So when they're asking for where it's undefined, they're really asking us for those vertical asymptotes. So to find where it's undefined, we're going to find the vertical asymptotes. So it's nothing new to us. We've already done this. They're just wording it a little different. All right, so that's where we said that the denominator would be equal to 0. And in this case, we can see up there nothing canceled, did it? So it's going to be where 2x minus 1 equals 0, and just solve for x. So add the 1, divide by the 2. And so this is going to be undefined when x equals 1/2. And this is important because I'm looking ahead. I see I want to know where it's positive, where it's negative. I'm going to do a sign chart, and then what does it want me to do? It wants me to graph it. So let's go ahead and graph what we have there. So we have the -3 and the 5 for our x-intercepts. Now, I'm not going to scale my y-axis because maybe all of my numbers might not fit on there. And let's go ahead and graph our vertical asymptote. Now, positive and negative are where we're going to have to plug in the numbers to find out if it's going to be a positive interval or a negative interval. So we're going to use the sign chart there to help us. What do we put on that number line? Okay, so negative infinity and positive infinity. The zeros. Is anything else going here? Yeah, the vertical asymptote. And so we're going to pick an x value in each interval. So I need a number between negative infinity and negative 3.
Oh, I like it.
Between negative 3 and 1/2.
0.
Between 1/2 and 5.
1.
And 5 to infinity.
6.
Everybody good with those numbers?
Yeah.
So we're going to plug those in. And we're going to solve. I really, honestly, well, we're going to need it to kind of help us maybe with the graph, but I'm going to show you how, when we go to graph this, I'm not actually going to use the number answer. I'm only going to use the sign. So let's plug in negative 4 into our function. And did you get negative 1? And then plug in 0. Again, you okay over there? All right, so look at this. Look at what it told me. Between negative infinity and negative 3,
It is negative.
it's all going to be negative. What about between negative 3 and 1/2?
It is positive.
In between 1/2 and 5?
Negative.
And between 5 and infinity.
Positive.
All right, so I'm looking at them. They alternated, so I don't really worry too much unless I think, oh yeah, I did have multiplicity, okay? Because then it shouldn't alternate, but we didn't have any multiplicity. Now, before, what I had you do was you grabbed that ordered pair negative 4 and negative 1, didn't you? But this time, I mean, look at the 0. It's all the way up at 15. Okay? So what this is telling me is between negative 8 and negative 3, my y values are all negative. So negative 3 is your y-intercept, your x-intercept. So you're going to start with it. So I'm right here at it, okay? And they're going to go down. Well, they're got to go down towards the negative infinity. So they're going to do something like this. They're just going to go down. And you could plot the point negative 4, negative 1 if you wanted to, and then draw your line out of it. That would be fine. But then on the next one, I had the order pair 0, 15. And I really don't want to go all the way up to 15. But I can tell, though, between negative 3 and positive 1/2, all of my y values are what? positive, which means they're all above the x-axis. So the negative 3 is your x-intercept, so that's where you're going to start at. You're going to have to go up, and since that's a vertical asymptote, we're going to go towards a vertical asymptote, and it's going to force it to kind of shape it on going up. And I know it looks a little demented, but it's okay. We can handle it. Everybody okay so far? Then we've got from 1/2 to 5. You told me that all of our y values are going to be negative. So 5 is my x-intercept, so I'm going to start at it. I've got to go towards the 1/2, but am I going to go up or down? Down, why? Because my y's are negative. So coming out of that 5, I'm going to go down towards that asymptote, which is going to force it to go on down. And then from 5 to infinity, you told me all of our y values are positive. So go to the one that's the x-intercept, which is the 5. Go towards infinity. And if they're positive, are they above or below the x-axis?
Above.
Above. So we're going to go above and go towards infinity. Now, the graph is a little hard just to come up with individually because, remember, we're always shaped towards some asymptote. Well, it didn't ask for it on here, but look at our equation that we started with, our rational function. It has an x squared on top and an x on bottom, doesn't it? So, therefore, the degree of the top is bigger than the degree of the top is bigger than the degree of the denominator by 1. So really there's a slant asymptote in there. It didn't ask us to graph it, but just so you know, there's one right in here, and that's why it's kind of shaped the way it is. Okay? I know. All right, so there's our graph. Now, it did ask me, I didn't do C and D. Tell me, where was it positive at? Where did we put our plus signs? Okay, yeah, so negative 3 to 1/2 and 5 to infinity. And where did we say it was going to be negative at?
Negative infinity, negative 3, 1/2, 5.
Very good. And you can see that on your graph there. All right, so that's example 2.